straightforward factorising. So if you've been asked to factorise, we know that we first of all have to make sure it's equal to 0. So we're going to have 3x squared minus 16x minus 12 equals 0. And the next thing we should always do is look to see if there is a common factor with all three of those. In this case, there isn't. And so what we need to do is we know we're going to have that situation where we're splitting the middle term. And we split the middle term here, this negative 16, by looking at 3 multiplied by negative 12 first of all. 3 multiplied by negative 12 is negative 36. So I'm looking for two numbers that multiply to give negative 36. And those same two numbers have to add to give negative 16.
Okay, 12 and 6. I mean 12 and 3.
12 and 3 wouldn't add to give negative 16. How about we have negative 18 and positive 2? Do we like those two? Yeah, you'd get there in the end, I know. So we're going to use these two numbers here to split this negative 16 in the middle. So I'm going to have now 3x squared minus 18x minus, plus 2x minus 12. Okay, then I'm going to split the middle term. Okay, so I've now got two different things I'm going to factorise. Look to see what's common on the left. I can see I've got 3x that's common. I know I'm going to want x minus 6 in my bracket because that's going to enable me to do the next step. And so that also helps me to know that I've got positive 2 at the front. And then I can see that my x minus 6 was common. And I'm left with 3x plus 2. Okay, that's obviously equal to 0 the whole time. So that's just straightforward factorising. If you had been asked to solve it, then you need to take, so if solving, you need to take it that one step further, and you know that your solutions are going to be x equals positive 6 because of this one here, and x equals negative 2 over 3. Remember, it's the opposite of this number divided by this value here. Okay, so they are your two solutions for that one. Another question we're going to go through is completing the square. Plus 3, thanks. Remember, often they will say write in the form a brackets x, actually they often say minus h squared plus k. Okay, so if you see anything that looks like that, that means it's going to be in completed square format. Okay, so going back to the question, we've got 2x squared minus 8x plus 3. We're going to focus on this part here for now. Remember, for similar to what we've just done, but what we're only wanting to do in these kinds of questions is to bring this number out to the front. So we're not looking to see what's common to both of those two terms, we're just looking to see to get rid of this number here. So I can see that 2 is common to both of them, so I'm going to write 2 brackets x squared minus 4x plus 3. So all I've done is bring my big 2 to the front. There is an x that's common to both of these two, but I want to keep it inside my bracket for this one. I'm then going to, which colour should I use? Okay, 2. I'm then going to open a big square bracket because now I need to complete the square on this part here. To complete the square, remember we focus on the number in front of the x and we halve it. So we will have x minus 2 all squared. We then have to subtract the square of this number here, so I'm going to write negative 2 squared just so we remember that that's where it's come from. Okay, then we have to bring in the fact that we have this 2 here. This 2 affects both of these things inside the bracket, so I'm going to have a big 2x minus 2 squared. This value here is 4. Okay, so negative 2 squared was 4, so this was minus 4. I'm then going to have minus 8 because I've multiplied it by the 2. And then I've got my plus 3 that I'm bringing back into play because I've got rid of my brackets. And then my final step is going to be to join these two terms together. So I've got 2x minus 2 squared minus 5. Okay, so I've written it in this new format. Now, the usefulness of this format is because it now tells us also what the vertex of the graph is, or where the vertex is. We know that the vertex is going to be at the coordinate 2, so in this case it's positive 2, negative 5. Perhaps I should have calculated that. Okay, so that's where the vertex is going to be. And that's one use of completing the square. We know it's positively happy. We can then also find our x-intercepts, our y-intercepts, etc., as we would do normally. Okay, but the key thing is that that's where our vertex is. It also has told us that my graph has shifted to the right by 2 squares. So my basic, if that was my basic quadratic graph, I know it's gone to the right 2 spaces, and it's also gone down by how many units? 5. So my vertex used to be here at 0, 0. My vertex is now down here at 2, negative 5. And this 2 here tells me it's got skinnier. Okay, so my new parabola is going to look something like that. Okay, so that's the link between the completed square form and transformations, but also sketching them and knowing where the vertex is. The other use of completing the square is to give us another way of solving it. Okay, so that's our completed square form. If you're solving 0 equals to x minus 2 all squared minus 5, we could then solve this without expanding our brackets. So we're going to add 5 to both sides. We're then going to divide by 2. Oops. We're then going to square root because we need to get rid of this square, so we're going to square root this side. Oh, I don't need my brackets anymore. And remember, when we square root, we've got plus and minus versions of it. And then our final step is to add 2 to both sides. So we've got 2 plus or minus the square root of 5 over 2. So we've solved it. We've got our two values, but they are exact values. So this would be something where it would be an exact value that you didn't have to use a quadratic formula.